so that I can upload it for anyone that that might not be in the session. And gotta go. Okay, so here we go. Let me zoom in just a little tiny bit here. So here's kind of the same instructions you're going to see on the assignment on Friday. Basically, you're going to be given a function. These lines here, the exact same things you found on yesterday's assignment. And then when we do the graph, and I'll talk more about that when we kind of fill in all these numbers, but I do want the graph to be reasonably accurate. Is it still a sketch? Yes, but it should be label some points and kind of show exactly what's going on. Also, yes. If you don't have a printer and you don't have like a 10 by 10 grid that you can put this on, I'm going to do it just on a normal piece of paper so you can see how it can be done without even one of these things. Okay. In fact, I'll do it on this one here, and I'll do it on the grid, and then I'll do it the same way just on a blank piece of paper and show you how you can do it without, even if you don't have a printer. Okay. But first things first. Before we even do the graph, we got to kind of analyze this thing. Remember, if you see a quadratic, the best thing to do right off the bat is factor it. And by the way, in all of these things, if you see a quadratic, it's going to be factorable. Okay, we're not going to give you one that's like a quadratic form or something like that. So make sure you know how to factor. So this is -2 and +2. And then this is -3 and +3. Okay. Now, most of these are going to use factored form to find these guys, which we talked about yesterday. A couple of them, particularly the Y-intercept, is going to be more used like the initial format. But let's kind of go on here. So, vertical asymptote. If you remember from yesterday, we find the vertical asymptote by setting anything on the bottom equal to 0 and solving. So since we have two different things, that's telling us we have two asymptotes. So it'll be at x equals 3 and x equals -3. Horizontal asymptote. Remember, this was one of three cases. It was either when it was bottom heavy, equal, or top heavy. And what that means is you're looking at the biggest exponent on the top and the bottom. In this case, there's an x squared and an x squared. So this is the equal case. So when it's equal, we take the ratio of the leading coefficients, in this case 1/1. So it is at 1, y equals 1. Also remember, if you have a horizontal, then slant is automatically none. It's either one or the other here, folks. It's one or the other. X-intercept. For the x-intercept, we set the top equal to 0 and solve, just like you did on the bottom. Now you do for the top. And again, there's two of them. So we have 2, 0 and -2, 0. Those are points, not just numbers. So make sure you write them as points. For the y-intercept, there's two ways you can think of it, and whichever one is easier for you to remember. You can either plug in 0 for all the x's. So you plug in 0, both the x's go, all of the x's go away, and you're left with -4/9. Or you can just remember it as the ratio of the constants. So in this case, it would be -4 over -9. And again, it's a point, so 0, comma, negative over negative is positive, 4/9. And the removable discontinuity, remember, that's just a fancy word for a hole. That only happens if something cancels out here. And if nothing cancels out, then there's no hole. Then you write none and move on. Okay. Now, how do I graph this thing? And just to kind of show you, I'm not going to, the rest of them I'll graph on the grid that I have here, but I want to show you how, like I said, just on a normal piece of paper, how you could graph this same thing by hand and still make it look reasonably good. Now, I am no artist, and I would never claim to be. Those of you that can draw and make art with your hands and different mediums, I will always be impressed by that, because I sure as hell can't do it. So all I'm going to do, I'm just going to make some tick marks on the axes, one line per. Try to make them evenly spaced. I'll say that's 1, 2, 3, 4. So you got that. And now we just start putting in the information that we have. When you put the asymptotes in, folks, write those as a dotted line, okay? I'm going to use a different color for the asymptotes just because I happen to have a couple different pens here. So I've got a vertical at 3 and -3. So at 3, I'm going to do a dotted line. At 3, and at -3, another dotted line. If you don't have different colored pencils or pens or whatever, I don't care. I'm just doing that just for kind of illustration purposes, so it's easier to stand out. Okay. Remember, vertical asymptotes, the graphs are never going to touch those. Okay, they're going to get close to them, but never going to touch them. Horizontal asymptotes, they might cross. They might not, but they might cross. So just kind of keep that in mind. My horizontal asymptote is y equals 1. So I go to 1, just go straight across here, something like that. Okay. Now for my points, so I have a couple of X-intercepts, 2, 0, and -2, 0. So I'm going to put those here and here. Y-intercept is 4 or 9. I don't know where that is, but I know it's less than 1. So I'm going to pretend like it's about right there. It's close enough. Now that's all I have. Okay. Now you're like, well, it's pretty clear that if it goes through this point and this point and this point, this middle section is going to look kind of like this. Right? But that's not the whole graph. There's got to be something else going on too, because there's got to be something in this section on the right, and then this section over here on the left too. So sometimes you won't have to do this. Sometimes it's going to be clear on what's going on, but sometimes you may have to kind of fill in another point or two to see what's happening. Okay. So I'm going to go back to the normal paper here. And I'm like, okay, well, I know I got to figure out something. So let's just pick a number. Let's pick a number that's less than -3 or greater than 3. Okay, something on this side. You can pick any X you want to, doesn't matter. Okay, so I'm just going to pick 4. So if I plug in 4 into the original function just to see what happens, that's all I care about, just see what happens. So if I plug in 4 for all the X's, then we have 16 minus 4, which is 12. And then we have 16 minus 9, which is 7, last time I checked. Now, all I care about, and here's kind of a shortcut on this. The only thing I care about is that it's greater than 1. Why do I care that it's greater than 1? Because look at where my asymptote is at 1, and I know at the ends here, it is definitely not going to cross the asymptote. So I know when x is equal to 4, it's above here somewhere. I don't really care where it is. But as soon as I know it's up here somewhere, then I can put the graph in and kind of get it approaching the asymptote. And I can do the same kind of trick on the other side. So I can plug in, heck, why not plug in -4? And notice you actually get the same number in this case. That won't always happen, but in this case it does. That's also going to be greater than 1. So again, at -4, I know it's up here somewhere. So the other piece is going to be like this. That's probably a little bit too pointy. Probably needs to be a little more curvy, but that's okay. And I am totally good with that. If you, the graph, can I get these on the same screen? Let me see if I can adjust my paper here. Yeah, there we go. So with this information that we found, kind of written out this way, and the points, you don't need to really label the points per se, because if they're here and I see them more or less where they should be here, life is good. Life is good. So I'm gonna let that kind of percolate for a second. And see if there's any questions about where any of the numbers came from, or why the graph shape was why it is. Again, about 80% of that is what we did yesterday. Just after we get that, then it's just plotting points. Yep. Oh, so like these guys right here. Basically, it's a great question. If you guys didn't hear that on the mic, Maurice asked, how did I know what numbers to plug in right here? Basically, I knew what happened in the middle section. I wanted to find out what happened on the other side of the asymptotes. So you just pick a number. The asymptotes were -3 and +3. So I'm just picking a number on the other side of those numbers. So like anything less than -3 or anything greater than +3. Does that make sense? You're welcome. And that's what you do. Again, we can make a good graph even if you don't have an actual graph, and if you have graph paper, even better, or a printer, but if you don't, it's okay. Let's go on to the next one. And again, the only reason I'm doing this is not an assignment, folks. This is just for your benefit, because you'll have an assignment on Friday. But it's going to be part of the test also. So it's just some additional good practice for you. So number 2, again, look and see if you can factor. Notice the first thing I see on top, 2, 12, 16, I can divide all of those things by 2. So I'm going to start off just by taking the 2 out. Oops, that's actually an 8, not a more good heavens. And then factor the leftover quadratics, just like we know how to do. So that's -4 minus 2. And this is -4 and +3. Now look what happens here. My x minus 4s cancel out. So I'm just left with 2 times x minus 2 and x plus 3 on the bottom. And now we just start cooking. Vertical asymptote, remember, we are looking for the thing, like we're using the simplest form of the function for a lot of these things. Okay, vertical asymptote, denominator equal to 0. So we just have the 1 at x equals -3. Horizontal, this is another even case, x squared on top, x squared on the bottom. So the leading coefficients, 2 over 1, so it's y equals 2. Horizontal, no slant. X-intercept, again, simplest form, x minus at the top equal to 0. So x equals 2, so it's the point 2, 0. The y-intercept is the other one where, again, I think it's easier just to go back to the original function. Again, all of the x's are going to drop out when you plug in 0 for x's. So you have a 16 over 12, or -12, I should say. Divide both those by 4, and you get -4 over 3. So it's a point 0, -4 thirds. And here is one that has a hole, because notice when those x minus 4s cancel out, that tells you you have a hole. And it's located when you set that equal to 0. So if x minus 4 equals 0, then x equals 4. So I know the hole is going to be at 4 comma something. To find out the y value, we plug that in to the simplified function. So we do 2 times 4 minus 2. You can just plug it in 4 for the x, over 4 plus 3. And that's equal to 2 times 2 is 4 over 7. I'm going to zoom back out so you can see the graph on the same screen here. Okay. Before I put these on the graph, any questions where any of those numbers came from? Again, it is always going to be that same process. Denominator equal to 0 for the vertical asymptote. Horizontal slant, that's your bottom heavy, top heavy to equal, in this case equal. X-intercept, top equal to 0. Y-intercept, the constants. The whole, if anything cancels out. So asymptotes, -3, only one. 1, 2, 3. Y equals 2. Intercepts 2, 0, so 1, 2, right there. Y-intercept, -4 thirds, a little less than 1. So -1, a little more than that. I should say a little more than 1. All right there, close enough. And then my whole 4, 4/7. So 1, 2, 3, 4, and a little bit more than 0, so about right there. But it's going to be an open circle because it's a hole. So on this section of the graph, and this is kind of the same question that Maurice asked a second ago. So on this section, I'm going to come up, go by the asymptote, come here, do a little hole, and then keep on going. So that's that section. But this is another one where I've got to figure out where the graph is on this side of the asymptote. Now, I'll tell you something, and here's a pro tip from someone who's been doing this for a long time. Okay? Notice there are no other X-intercepts. So the only X-intercept was here. So it cannot be in this section because there's no X-intercepts. And remember, it can't cross the asymptote, and it's not going to cross this asymptote over here, so it has to be up here. Okay, so you could plug in a point, like, again, my asymptote is -3. You could plug in -4 or -5, whatever, just to see what the value is, but it's going to be greater than 2 all of the time. So I'm just going to graph the sketch a section up in here, and that's what my graph looks like. Okay, so you can use a little bit of common sense in saying, okay, that's my only X-intercept. There's nothing here, so it's got to be above the asymptote that whole time. Okay. Questions, comments? I'm going to try to get through the last 2 before we run out of time. I think I can because the last 2 are a little bit easier, honestly. There's not a hole. There's something in the chat box. Let's see here. So John, I saw your question from number 1. Sure. So we're looking for how does it ever look like how we've gone out a little bit, but it's more. How can I say this? So the reason, like on number 1, the reason I plugged in 4, all I cared about was it's greater than 1. The reason that's all I cared about is because of where the horizontal asymptote was. Okay, so because the horizontal asymptote was at 1, and I know it's not going to cross that asymptote on the ends, then as soon as I know that one value over here is bigger, as above that asymptote, then the whole section of the graph is going to be above that asymptote. Does that make sense? Okay. And then the same thing, like with number 2, I could have plugged in a point, you know, -4, -5, whatever. But again, I kind of used some common sense saying there's no X-intercepts, so it can't be down here. Because down here, it would have to cross the axis somewhere. So it's got to be above the asymptote on that other section. Okay. Appreciate the question. Okay. Numero trace. Here we have a top-heavy case. Notice I got an x² on top. This is an x-3 on the bottom. Let's factor it first, though. And again, for the sake of time, I know you guys know how to factor. This is going to be x-2 and 3x-1 over x-3. Notice nothing cancels out. There's no hole, nothing like that. So we can just kind of start in with a business. Vertical asymptote, bottom. So X equals 3. I seem to like 3s, but that's okay. Horizontal asymptote, again, we just said it's top heavy, so there's not a horizontal. There is a slant, so we have to divide. I'm going to do that down here. So if it is top heavy, do your polynomial division. So x and 3x squared. Always subtract. X and a 2x. Now the good news here, once you finish that up, you don't care about the remainder here. The remainder is 8, but this is what you care about. This is your slant asymptote. Y equals 3x plus 2. No remainder, don't worry, we're not worried about the remainder part. X-intercept, top equal to 0. So again, set each piece equal to 0. So 3x minus 1 equals 0. So x equals 1/3. So it's 1/3, comma 0, and 2, comma 0. Y-intercept, constants, because all the x's are going to drop out. So 2 over -3. Nothing cancel, no hole. Start graphing. 1, 2, 3. Slant asymptote, 3x plus 2. Don't forget your algebra 1 skills. Y-intercept to 2, up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. Not too far off the graph. 1, 2. You can go backwards if you want to. There's that. Stick your points in there. So x-intercept at 1/3, so that's just barely more than 0. So like right there maybe. 2. And then the y-intercept at -2/3, so that's like right there. So we have this piece right here, so you can see, again, just following those points, it's got to kind of come up like this. Now here, these can be a little bit tricky, I'm not going to lie, because we definitely have that section, totally good. These slant asymptotes, guys, they are always going to be in opposite sections. So if I have a section right here, my other section is going to be way up here. I'm not even going to bother plotting points. I'm just going to stick a little tiny arc up there and pretend like that's it. Let me say this too, folks. I got about 9 minutes. I'm going to try to do this last graph real quick because it's a bottom heavy. This one goes even faster. Guys, you have technology at your fingertips, okay? We understand that as your teachers. You understand that because you are in the technology age. Listen, I am not opposed to you using technology that you have available to you, such as Desmos, and checking to see that you have these things right. Now, just like we did on the polynomials test, we are going to write some questions to where the calculator may not be as much of a help. But the important thing is, if you're using something like Desmos, make sure you know how it's happening. Okay? Again, I am not opposed in the slightest to using technology that you have to help you out with this. Okay? But use it to help you understand the concept. Okay? Last one. I changed the function last minute. On your paper that you see in Schoology, you see this, x minus 1 over this. When I first did it yesterday, I had something else, but I changed my mind last minute. So I had to hand write it in. So x minus 1 over x squared plus 3x minus 10. There's another 3. I'm obsessed with 3s today. I don't know why. Factor the bottom. X minus 1 over x plus 5, x minus 2 to get that. Nothing cancels. So that's it. Vertical asymptote, there are 2 of them, -5 and +2. This is a bottom heavy case. X on top, x squared on the bottom. So it is automatically y equals 0. Nothing to even think about. If it's bottom heavy, y equals 0 all the time. X-intercept top. So x equals 1, so 1, 0. Y-intercept constants, -1 over -10, so 1/10. Nothing cancels. And this is going to be the question similar to what John asked, Amaris, and probably a couple other interviews that just didn't say anything. Draw my asymptotes in. 1, 2, 3, 4, 5. 2. 0, horizontal. So again, think of it in terms of 3 sections. Something's happening in the middle, and then something's happening on the 2 ends. Let's see what points we have. We know a y-intercept, sorry, x-intercept at 1, so there's 1 right here. And there's a y-intercept at 110, like right there. That's all I know. But again, just think about what it means for an asymptote. So if this whole thing is 1 section, right? Between the asymptotes, something happens. And it's got to approach both of these asymptotes. So it looks like to me, like, you see this whole section here, it's got to go from here to here. So it's going down. So that means it's going to kind of go down like this towards that asymptote. And then to the left, it's got to be going up like this. Because again, there's no other x-intercept. There's nothing happening over here. For these 2 sections, and again, this is exactly what John and Amaris were saying, pick a number. Plug in a number greater than 2. So let's plug in 3. So if you do f at 3, I can do 3 minus 1 over 3 plus 5 and 3 minus 2. I don't really care what the number is. 2 over, what's that, 15? It's greater than 0. Because remember, my horizontal asymptote's here. If that's bigger than the asymptote, then it's got to be up here somewhere. Plug in a number less than -5. So let's say -6. -6 minus 1, -6 plus 5, -6 minus 2. -7 over -1 times -8, which is 8. But it's negative over positive, so it's less than 0. So it's got to be down here. I know I finished that last one up kind of quickly, guys, because I felt like I was running out of time. I still got like 5 minutes. But I will upload this video going through this, so you can kind of pause it and go back and see the different steps and stuff like that, and see and make sure you can do that. Friday, work day on doing 4 just like this. It'd be different equations, obviously, but it's the same kind of deal. Okay. And we have 5 minutes. Let's ask the questions. What do you want to, is there anything that you want?